All right, welcome. Welcome, everybody. Welcome to the State of SAML. The State of SAML it's still here. Thank you for coming. Okay, great. Welcome to the State of OAuth. I'm Aaron Parecki from Okta. I work on identity standards at Okta and participate in the OAuth working group at the IETF and OpenID Connect as well, and do some OAuth education and training as well. So I am all over this stuff all the time and thinking about it all the time, and happy to share it with you all here. So there is a lot to cover, but I do want to give a quick summary of kind of bring everybody up to speed on setting the baseline for what OAuth is. You might be familiar with OAuth from buttons like these. You sign in with Facebook, sign in with Google. Is this OAuth? Well, yes and no. It's a use of OAuth, kind of a misuse of OAuth for sign-in buttons, but they're usually built on OAuth at the very least. But OAuth was originally created to let applications access data, which is a very different problem than actually signing into applications. And in particular, OAuth was created to limit what applications could access. So for example, letting a third-party application access one type of data from an API while preventing access to a different kind of API. You can kind of think of this as similar to checking into a hotel, where you don't get free reign of the hotel. You go to the front desk and check in, and you get this key card. You take your key card to your room, and you swipe that on the room, and it lets you in. You get access to your room, the elevator to your floor, maybe the pool, maybe the front door after hours. It's a way to limit the resources of the hotel that you can access. And this is very similar to OAuth granting an access token to access limited set of resources of an API. So I'm sure you're familiar with what this actually looks like in practice, which is you're on one application and then you click a button, whether it's a sign in with or connect to your account button. You get redirected away from the application over to the OAuth server. That's where you log in. You enter your password over there. You might also get prompted for a second factor of authentication, and then eventually get redirected back to the application. Meanwhile, that application had no idea really of any of the details of those steps of you actually logging in. And this is true whether we're talking about first-party or third-party apps now. Originally, it was created for this third-party delegation problem, but we've seen a lot of applications of OAuth in first-party scenarios as well. So starting with OAuth 2, which actually was published quite a long time ago now, October 2012, if I remember correctly. I want to give a quick recap of the flow, of the OAuth flow, because we're going to look at how all the different parts of OAuth have changed over the last, now, I guess, 12 years almost. And I want to talk about how they relate to which parts of the OAuth flow. So in OAuth, we talk about a client application, which is the one that's trying to get access to data or sign the user in. And that application, the user interacts with that application through their user agent, which is typically a web browser, but could be a mobile app, a mobile phone as well. That application, that client app, ultimately is trying to get access to resources in the resource server, typically called an API now. And in order to do that, it needs to get tokens from the authorization server. So the typical flow looks like the client telling the user agent or the browser to redirect the user to the authorization server, where they then sign in. The authorization server will then issue a short-lived credential called an authorization code back to the client application, which it can then exchange directly with the OAuth server for an access token. And then it can use the access token to make API requests to the resource server. The resource server obviously needs to be able to validate the access token somehow, and there's a bunch of different ways that it can do that, one of which is going back to the authorization server and asking, hey, is this token valid? In which case it'll get a response. So what we're going to do is talk about which of these legs of the flow, each of these different extensions of OAuth actually touches. So this is the sort of base what we come to think of as OAuth, it's the authorization code flow in OAuth. And that's defined in RFC 6749, the OAuth core spec. And then the use of access tokens is actually defined in a second spec, the bearer token spec, so 6750. And the OAuth core spec defines not only the authorization code flow, but also a couple other flows, different ways to get access tokens. And the bearer token spec has a couple of different ways of using access tokens. Since then, a number of extensions have been published to improve the security of the flows, one of which is PXE 7636, which is a way to protect the authorization code flow for usable by any kind of client now. The 8252 is a best practice for native apps, which, among other things, recommends using PXE for mobile apps. And we also have, a few years later, the security best current practice, which talks about the best way to do, the most secure way to do the most common OAuth flows, which says a whole bunch of things. It is worth a read if you're implementing this stuff from scratch. But among other things, it deprecates the implicit flow. It deprecates the password grant. It says PXE should be used by all clients, not just mobile apps. Even if you have a client secret, PXE still has some protections that you benefit from. There's also the browser apps best current practice, which recommends using PXE for single-page apps in a browser. And by now, you're probably thinking, how do I even understand where to start when you're building things? Like, this is just a giant mess of RFCs. And all you're really trying to do is just build your app. So how can you possibly navigate all this? And I don't blame you for that at all. So one of the interesting things, though, is that if you actually look at what is left of OAuth 2 once you apply all of these best practices and extensions that have been created over the years, it's actually a lot simpler. It's use the authorization code with PXE, or use the client credentials grant if there's no user. And there's a couple different ways to use tokens. Don't send tokens in query strings, basically. So this is the baseline set of behaviors that we expect when we talk about OAuth 2 today. This is what we would consider the most secure version of the plain OAuth spec. And that is what we are trying to capture in the OAuth 2.1 update. So OAuth 2.1, it is still in progress, although we are slowly chipping away at all the tasks. The goal of OAuth 2.1 is basically to consolidate all of the OAuth 2 specs that I just mentioned, adding best practices, removing deprecated features, basically capturing the best way to do OAuth 2 under a name that we can actually refer to rather than having to say 5 different RFC names. And among other things, there's been a lot of activity in the last decade around OAuth, and there's a lot of opportunity to point people to some of the new, more interesting extensions that provide new features or new security properties. So a lot of those now we can reference in the 2.1 spec so that you can at least know that they exist without having to go, again, read through pages and pages of documents. So I want to now talk about some of the more recent OAuth extensions that have been published as RFCs. And we'll talk about which legs of the flow they refer to. Starting with push authorization requests. So in the auth code flow, in the traditional redirect model, the client starts the flow by redirecting the user to the authorization server, which means actually the first time the authorization server sees the user, it doesn't see the client directly. It gets that request from a browser. Pushed. What just happened? PowerPoint just quit. Okay. We're back. Weird. So push authorization request changes this and instead starts the flow from the back channel, where the client talks directly to the OAuth server to start the flow, gets back an artifact which it can then send the user off in a redirect. So this gives us a couple of security properties already. One of the most obvious ones is that, well, if the client is starting the flow by redirecting the user, then that redirect is visible to the user and the user can modify the request, which means that the authorization server doesn't really actually know if the client sent that request or if it was just a request that was messed with for some reason. So something is... Okay. Yeah, the slides are just going away on mine. Something is stealing focus. Okay. Yeah, you're good up there. It would help if I can move to the next slide. So push authorization request changes the flow to start from the back channel. So basically, instead of a GET request that the browser would have made to the authorization server, first the client sends a POST request, which means it can, if you do have a confidential client where it has credentials, it will be able to use those credentials to start the request, and now you can do things like actually know for sure that the client made this request before it even hits the browser. JOT authorization request is another way to secure the use of the front channel. So instead of building all the request parameters in the redirect, it's going to create, the client will create something. There are ghosts on this computer. I swear to God. Okay. So instead of the client putting all the request parameters in a query string and then sending that to the authorization server, it'll build a JOT with all the same parameters, which means it can sign it using a private key and send the signed request over to the OAuth server. And you can combine this with PAR if you want as well, but this basically is another way to protect the integrity of the client's request so that the authorization server knows that that client actually did create that request. I know I'm going very quickly through these, so I hope that you will at least take some photos of these and dig into the ones that you're most curious about if you do want to learn more, because we do not have time to go into all the detail that I would love to talk about each one of these. But, okay, authorization server issuer identification is a very long name. It's a relatively recent extension, actually, and this one was one of the fastest I've seen go through the RFC process, but I think that's because it's a relatively simple mechanism that protects against a very clear and well-scoped attack, which is only if the client, it's only relevant if the client interacts with multiple authorization servers. So it's adding a new parameter in the response from the authorization server back to the client with the authorization code. What it's doing is basically if the client interacts with multiple authorization servers and uses the same redirect URL, when it gets a redirect back with an authorization code, it doesn't actually know where it came from because, again, it came through the browser and not from the authorization server. So this is a way to include a parameter where that identifies the issuer of this authorization code, which is interestingly protects against the attacks that are relevant, even though it's not signed or anything, which is somewhat surprising. But again, if you are curious, go read the actual docs because it goes into details about how it works. The good news is that it is a single parameter that gets added to the response, and the client is expected to just compare the value with what it expects. And that means it's actually very straightforward to implement on both clients and servers, which is probably what helped the spec get finished so quickly. Another recent RFC is the step-up authentication challenge spec. So this one is a way for the resource server to indicate to a client that the current access token that it used in a request isn't sufficient for some reason. And this is not necessarily coupled with the use of JOT access tokens, but that would be a common way to implement it, which is that the access token might contain like ACR values or some indication of how the user authenticated when they did authenticate at the authorization server, and the resource server can say, well, that's not enough. If this access token was issued only with a password, then I want you to do step-up auth and get me a new access token that has some sort of MFA claim in it. You don't have to use JOT access tokens to implement it, but that is, again, a common way that people would implement it. So this is a way for a resource server to respond, telling the client to get a new access token that meets new requirements, and the client is expected to send the user through the OAuth flow again with an indication of knowing that it needs to include a request parameter that says I need MFA or I need a particular type of step-up auth. Rich authorization requests. I think I saw a session about this. I don't remember if it was today or tomorrow. So if you're curious about more of the details of this, again, there's another session. Rich authorization requests affects the client to authorization server start of the flow. So typically in OAuth, we would describe a request in scopes. We would say this client is trying to get access to the user's photos or the user's documents or email, or they're trying to send email. And all of those things you can describe with scopes, which is, but it's a very limited mechanism. You can define scopes with any amount of structure you want, and some people have defined their scope vocabularies to be actually structured, like data structures with expressions and Boolean logic in them, which is a bit of a confusing when you go look at it. And you can make it work, but this is a way to create a more expressive vocabulary to do that kind of thing. So while scope lets you request access to a finite list of things that have been documented as scopes, and at best with some sort of greater than expression in them if you really want to push it, ideally, we would have a better way to describe those kinds of fine-grained access requests. And importantly, so that the authorization server can actually present this to the user in the user interface. So for example, if you wanted to create a interface that said, this app is trying to pay this particular merchant this dollar amount from a bank account in order to express those pieces of information, that isn't really scopes. You can't really express that in scope. Instead, you have to express it with a richer vocabulary, which is what rich authorization requests does. Okay, so these are all some recent RFCs that have been published. There's a lot more work going on that is not yet an RFC, but is very nearly final. JOT response for token introspection. So I mentioned at the beginning that a resource server needs to validate an access token somehow. If you're using JOT access tokens, then the resource server can validate the JOT. If you are not using JOT access tokens, then the resource server either is doing a token lookup in a database or doing token introspection, making an HTTP request back to the authorization server. The authorization server would then say, yes, this token is valid. If the resource server needs to actually hold on to something that proves the authorization server said the token was valid, you can use this to accomplish that. So basically, the authorization server returns a signed JOT, a full signed JOT saying this token is valid, and maybe the details of the token at the time, and it's signed, which means the resource server can log it and use it to prove later that it was, in fact, the authorization server that said the token was valid, and that it didn't just make up that answer on its own. OAuth for browser-based applications. This is one of the ones I've been working on. This is now in working group last call. It doesn't necessarily affect too much of the flows, but it does talk a lot about best practices for how browser-based apps should be using the rest of the OAuth world, including things like talking about the trade-offs about the different token storage mechanisms or different architecture patterns about should you use a backend for front-end versus using a service worker versus pure JavaScript app. And the goal of that draft is basically to collect all of the trade-offs, because there's no clearly correct answer. There's always trade-offs. So that document is at least meant to collect them all there so that you can get the best picture when you're deciding which architecture to use. Another topic that is now we're getting into some of the more less clearly solved parts of OAuth. Sender-constrained access tokens have been a problem for a very long time. This is the idea that if you have in OAuth core, access tokens are what we call bearer tokens, which means if the client, whoever has the token, can use it. So the token is the representation of the authorization and the access. So just like a hotel key card, if you have the key card, you can use it. Doesn't matter where you got the card from. If I give you my hotel key card, you can go and use it on the elevator in my room, and that door has no idea that it's anybody else using it, right? This has some interesting problems, many of which end up with very public hacks that have taken place. One of my favorite ones being the YouTube channel takeover hacks, where it's essentially a cookie theft problem, which cookies are also bearer tokens. So if you can steal cookies, then you can just present them to the web server and you look the same as the legitimate browser. And then they go and take over YouTube channel and do live streaming crypto scams, which is great. But the whole point of this is that the problem is the bearer token, which is that it's the same thing that is issued by the authorization server is the same thing that gets used. And that means it can be copied and stolen, and there's no indication that that's happened. So if the problem is that bearer tokens can be used by anybody that has the bearer token, then actually what we need is we need to require some sort of authentication of the thing that is using the bearer token. And that is where we get into the different options here, because the some sort of is debatable, and what exactly client instance means also is different depending on who you're talking to and what you're talking about. There have been many attempts to solve this over the years. However, finally, there are a couple of RFCs that do a good job of this. Mutual TLS is a older one which does solve the problem but is difficult to deploy. Depop is a relatively new RFC which binds an access token to a private key, but it's all done in the application layer rather than the transport layer. Signed HTTP requests can be used for this, although it doesn't actually have an OAuth binding at the moment. And these are the two that didn't ever really make it through the process. So there's another tangentially related part of this, which is that browsers are also trying to solve this for cookies. So it's not exactly an OAuth thing, but it is essentially solving the same problem. There are two in-flight proposals for this by Google and Microsoft. These are the links if you're curious about those. A couple of getting into the really experimental stuff, a couple of the emerging themes I want to touch on, and we do not have time to go into the details of these, so these are mostly just to point you in the right direction for where to go further. One of the ones I'm excited about is client attestation. So this is a common problem if you don't necessarily trust the if you are shipping a mobile app or a single page app where it's not a confidential client. How do you actually know that that is your app making requests to the server? It's an interesting problem. There's a lot of implications of what that means for different deployments. There are existing attestation APIs, but how do we then apply it to OAuth? There's been some discussions about how we might do that in a standardized way. There's also some interesting work going on in token chaining, which is not. It's essentially when we're looking just at the resource server as an API, but that API is actually made up of a bunch of different parts. How when the request comes in and then it needs to go and hit all the different other internal services, but you don't necessarily want to use the same access token all the way through, especially if you want to start doing things like device-bound or instance-bound, client-bound access tokens. How can you use some sort of thing to exchange tokens for other tokens that you can use for downstream services? So there's a couple different proposals out there for that right now. There's also cross-domain problems, which are a similar kind of token exchange problem where if you need to use an authorization server from one domain to access resources in a different domain, how do you establish the trust relationships, but how also do you do the token exchanges? Then there's we talk a lot about logging in, but there's, of course, the whole revocation problem. There's a couple of different revocation drafts out there, but one of the missing use cases is get rid of everything right now, like actually log this user out. So this is a draft I've been working on that talks about that. And then one of the last pointers I want to give you is around the FedCM, Federated Credential Manager API, which is very, very in progress right now, and not. While this is not an OAuth problem, it has a lot of implications in OAuth about how we might need to modify OAuth or OpenID once things like third-party cookies are no longer possible to use, or even what happens if link decoration and redirects stop working the way they always have. So if you are curious about any of these, I have links to everything up on OAuth.net, and I also want to just plug a couple of talks that are coming up tomorrow that are related to this as well. So thank you all very much.